Today we're going to talk about section 7.8, reflections. And reflections are just another type of transformation. If you'll recall, last time we talked about a transformation called translations. Translations, if you will recall, were something similar to this. They were this. Here's an example of the red triangle. The red triangle, if you will direct your attention to point -5, 1, right there. -5, 1, right there. We would have, the translation could be described as xy translates to x plus 6, y minus 4. Okay, so on the y-axis we did 4 jumps down, and then on the x-axis we did 6 jumps right because it's plus 6, and we end up with this point right there. Now you could also just do math if you don't want to be going cross-eyed with the graph, going cross-eyed looking at the little lines on your graph. You could go look at the point, and it's -1, 0, and you could go -1 plus 6, and then 0, which is your y value, minus 4. Okay, -1 plus 6 is going to be a plus 5, and the y is going to be a -4. And that gets you 5, -4, which is right there. Then you can look at your third point, which is -3, -1, and -3 plus 6 is going to be a positive 3, and -1 minus 4 is going to be a -5, and that gets you your third point, which is right there. Then we connected the dots with the orange lines, and we have translated this image. Remember, translation is going to result in a rigid transformation. My orange image is the exact same shape and size as my pre-image, which was the red triangle. So the red triangle was my starting point, so it's called the pre-image. And my orange triangle is my ending, my resulting shape on the Cartesian plane, so it is my image. Alright, so that was a quick review of translations. But today we're going to talk about reflections. Reflections are going to be another type of rigid transformation. We are going to end up with a congruent shape. So this is another type of transformation in coordinate geometry, and coordinate geometry is once again that fun geometry where we're going to be dealing with shapes on the Cartesian plane and manipulating them, doing things to them, moving them. And this kind of math would be used in video games, among other things. But one that you might be familiar with would be video games. The book had also mentioned engineering and space exploration. So it's an interesting branch of mathematics. So if we are looking at reflections, for the purposes of this book, we are going to use the x-axis or the y-axis as our line of reflection. Remember, a reflection is simply you have this line of reflection and some shape, and you're trying to get this to be the mirror image of that shape. So it would be something like that. And this was the line of reflection. Line of reflection. Well, once again, for the purposes of this book, we are going to be using the y-axis or the x-axis as that line of reflection. And so some interesting things happen to the coordinates when you do this. So let's look at reflecting this black shape right here across the x-axis, and we will do that with yellow points if they show up good. So this is -2, 1. We're going to stay at -2, but we're going to go down to a -1. -2, 3. We're going to stay at -2, but we're going to go down to a -3. -3, 4. Once again, stay at -3, but we're going to go down to a -4. 1, 2, 3, 4. Here, this is -5, 4. We're going to stay at -5, but we're going to go 1, 2, 3, 4, down to -4. And then this one right here is, I did not write what it was, so I've got to count it out. 1, 2, 3, 4. It's a -4 and then +2. So we're going to stay at -4, but we're going to go down 2. So we end up with those dots, and then we just need to connect them. And we end up with that shape. And you'll notice that when you reflect across the x-axis, you have flipped that shape vertically, and you've multiplied your x values stay completely the same, but your y values have been multiplied by a -1. This point is -2, -1. This is -2, -3. The yellow kind of hurts the eyes. This is -3, -4. This is -5, -4. So you'll see that our x values have remained the same, but we've had to multiply the y value by a -1. Now if we reflect it across the y-axis, let me pick a different color. All right. The -2, 1 will stay. We're going to stay at -2. We're reflecting across the y-axis now, but we're going to come over here. We're going to stay at 1, but we're going to move our -2 to a +2. Then we're going to stay up here at 3, but we're going to move the -2x to a +2. Then here, this is -3, 4. We're going to stay at 4, but we're going to go 3 to the right. So this is 3, 4. This point was 2, 3. This point was 2, 1. All right. This point is -5, 4. We're going to stay at 4, but we're going to go to a +5. So that was 3, 4, 5. And then this final point is -4, 2. We're going to stay at 2, but we're going to go to a +4. And then we just need to connect the dots. All right, so this purple shape has the reflection across the y-axis. And you'll notice that my y values stay the same, but my x values multiply by a -1. So we see two things happen when we reflect on y-axis multiplies the x by -1, and it flips the shape horizontally. All right, but if we reflect on the x-axis, like we did with the yellow shape, and I'm so sorry about that color, it really hurts the eyes. Reflect on the x-axis, we multiply the y value by -1. This multiplies y value by -1, and it flips the shape vertically. All right, so understand those two things happen when in the difference between how the shape will look if you reflect on the x-axis versus the y-axis. All right, the last thing we need to talk about is there's the possibility that you are going to be asked to determine if a shape is congruent. Remember, congruent means same shape, exact same size, same area. So in order to do that, sometimes you might have to do a reflection, sometimes you might have to do a translation, and sometimes you might have to do both. For example, if you were asked, does this green shape right here, is it congruent to the black shape? Well, if I reflect, I get this purple shape, which is very, very close to that green shape. But now there's something I need to do to the purple shape to put it on top of the green shape to find out whether or not it is congruent. And I need to translate it. I need a translation of the purple image to move it on top of the green image. So to get, I can see that this, let me move to what color? Dark blue. All right. I can see that this 2, 3 would line up with that. So how can I get from 2 to this new point over here? Well, that this new point right there is 1, 2, 3, 4, 5. It's 5 on the x-axis and 1, 2, 3, 4, 5 on the y-axis. It's 5, 5. All right, so to get from a 2 to a 5, what do I need to add? I need to add plus 3. And to get from a 3 to a 5, I need to add 2. So my y would be y plus 2. So now I need to apply this translation, x plus 3, y plus 2, to every point in the polygon. And if every point ends up on the green, then I have the same shape. It's congruent. So I've already moved my first point which is reflected with the 5, 5. So now let's look at the next point. The next point is 3, 4. We're looking at the reflected shape, which is purple. It's reflected from the black. All right, so 3, 4. 3 plus 3 is 6, and 4 plus 2 is 6. 4 plus 2 is 6. So we get 6, 6. Or I could go, I'm here now, and I want to go up 3. 1, 2, 1, 2, 3, and then I want to go right 2. 1, 2. Hang on a second, let me make sure. 3, 4. Is that my point? 1, 2, 3. 1, 2, 3, 4. Okay. And I did the math of 6, 6, so it seems like I'm going to a different place than I was anticipating. So that's the reason I'm trying to double relook at my. I think that I messed up. Sorry. All right. So if I'm looking at 3, 4, I can go x plus 3. I think I went up 3, and I did. That would have been y plus 3, so I apologize. X plus 3 would get me 1, 2, 3 right here, and then up 2 would get me here. And the math of that point was 6, 6, which is there. All right, so the next point is right there. And the original point is 1, 2, 3, 4, 5 on the x, and then 1, 2, 3, 4 on the y. 5, 4. So let's plug it in to the equation x plus 3, y plus 2. So x plus 3 is going to be 5 plus 3, or 8. And then y plus 2 is going to be 4 plus 2, or 6. And we get 8, 6. So we'll go 1, 2, 3, 4, 5, 6, 7, 8 on the x, and up 6. 1, 2, 3, 4, 5, 6. And we end up right there. It's looking like the shape is going to be congruent. And it does kind of look like it from the eyes, but still. The next point is 1, 2, 3, 4. And 1, 2. 4, 2. That is this point right there. Okay, so 4 plus 3 is 7. We're plugging it into this formula. 4 is my x, so 4 plus 3 is 7. And y plus 2 is going to be 2 plus 2 is 4. So my new point for this one right here is 7, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And I end up on the same shape. And my last point is 2, 1. So I'm going to plug that into the equation. X plus 3, now that's going to be 2 plus 3, which is 5. And y plus 2, which is 1 plus 2, is 3. 5, 3. So we go on the x-axis to 5. 1, 2, 3, 4, 5. And we go on the y-axis up to 3. Every point is exactly the same. If we were to connect those dots, we would end up with the exact same shape. Every point's the same. The two shapes are congruent. But they did require, remember the pre-image was actually the black one, and the blue-green image now is the image. And it required the reflection on the y-axis and then the translation to determine that they were indeed congruent. All right, so avoid my mistakes. Don't be going up when you need to be going right on the x-axis. So good luck, and if something's not looking right, it's okay to pause. It's okay to check and make sure that you're not making a mistake. Good luck.